is the durability of concrete. So let's see what is meant by durability. So here figure indicates the concrete. So interaction of concrete with environment in which concrete structure is located, that comes under the durability concept. So this interaction happens largely through the hardened cement paste. Henceforth we are denoting it as a HCP, that is hardened cement paste, by way of permeation of material from the environment into the concrete and their reaction with the internal constituents. So internal constituents may be the aggregates, and this external constituents may be the air, water, and its extra. In limited cases, sometimes these constituents may react with the aggregates also. Hence we need to better understanding to classify the environments where the concrete structures are built. So parameters for classification of environments: chemicals, temperature, presence of water, and other parameters. So in chemicals include, there may be a chlorides, sulfates, iron, etc. Temperature, sometimes it may be a freezing temperature, or sometimes it may be a temperature which is more than 40 degrees Celsius also. Sometimes, for example, if we construct the bridge pier, sometimes there is a presence of water and sometimes it may not be. So, and other parameters are also. So depending upon this requirement, we may need to change the contents. So what are the contents in the concrete? Maybe cement you have to replace. So sometimes we have to use the sulfate resisting cement, chloride resisting cements, rapid hardening cements. So depending upon the situations where we have to construct the particular structure. Then we can change the water cement ratio also depending upon the situation or the environment. So cover to the reinforcement. So this cover to the reinforcement may be played for the structural point of view as well as for the durability point of view also. So this cover to the reinforcement. So cover to the reinforcement act as a shield, or we can say the protection from the environment of that reinforcement. Also the crack width. When the beam is subjected to flexural, so there may be a flexural cracks, and these flexural cracks will be developed when this beam is subjected to loading. So depending upon the crack width, so we have to maintain or negotiate that crack width depending upon that. So we must have to consider that also. So let's see the different examples. So in order to understand the durability in better manner. Diverse nature of environment in which concrete structures are built. So these are some examples of diverse nature. So for example, gravity dam and the bridge piers. So gravity dams are subjected to different environment as compared to the bridge piers. As well as itself, in gravity dam, the different parts of the structures are subjected to different environmental conditions. In case of bridge, if you see that this pier, some parts of the pier is submerged into the water and some parts are over the water. So this pier itself having the different atmospheric conditions. Sometimes it is pier subjected to cyclic action of wetting and drying also, and some part of this pier which is below this water is always submerged into the water, and some part of the piers, we can say that the foundation which is resting on the bed of the sea or bed of the river, having the different environmental exposure. And this deck slab also, where there is always it's subjected sometimes splashing of the water or tidal waters. So in one structure there is a different environmental conditions. So care must have to be taken that it must have to be sustain that structure with a different environmental exposure. So durability is comes here. Then another structure, offshore. So this is parallel to the, we have already discussed the bridge structure or the pier structures. That some cases for the offshore structure also. Then we come towards the tunnel. So in tunnel, the top part of this tunnel is subjected to soil pressure and which is always in contact with the earth or soil, and the underneath part of this tunnel is always subjected to air. So in the same structure or same structure, there are the two different exposure conditions or two different environmental conditions that we must have to be considered while designing the tunnel. Now, now look at our this special type of structure. This is shell structure where thickness of the concrete member is very small, and the reinforcement which is placed in this concrete is very dense, and it is a special care must have to be taken while designing this special type of structure. The another example is the railway sleepers. These railway sleepers are always a precast members, and where it is a thermal curing may have to be considered while designing this railway sleeper. So it is also subjected to the different exposure or different environment. Now, if you see that this figure is shows you the sparing of salt in a cold climates leading to the accumulation of chloride in a part. So what happens in order to remove the so in front of you there is one picture of the pavement slab which is subjected to the snowfall. So in order to remove this snow from this pavement, sometimes salt is used. So when this salt is used, so from that slab there is chances of penetration of chlorides into this pavement slab. And sometimes when it is made, this salt or these chlorides are attached to the wheels of the vehicles, and when these wheels or the vehicles are going into the parking, so the parking deck also subjected to the chlorides. So care must be have to be taken that it becomes the impermeable. This pavement should be impermeable, so there may be less chances of chloride attack. Then if you see that deterioration in concrete structure, that is reinforcement corrosion. This figure shows that there is a very corrosion of reinforcement of the piers. So there is a loss of cover. So we must have to be understand. So what is the service life of this structure, and in which situation it must have to be sustained or it must have to be remain over there. So so this is our responsibility. This is the responsibility of our engineers that design concrete structure. During service life of structure, the required amount of functionality or required amount of structural integrity must be there. So during what is the service life of the structure? In that during the service life it must be structurally integrated. So there should not be any compromise on the structural integration. So care must have to be taken while designing the concrete. So this figure is self-explanatory. If you this is a figure of the pier, a bridge pier or beach. So various deterioration phenomena in concrete exposed to sea waters, that from this figure it is clearly understandable. So the some part is not subjected to the sea water. Some parts are submerged, partially submerged, and some parts are the completely submerged. And below this is below the seabed. So in one structure it is subjected to different types of environment. So care must be taken in such type of structure while designing the concrete. So if you see this, so this is show the deterioration due to the structural failure. This is due to the alkali aggregate reaction. This is nothing but the loss in durability of the concrete. This is not a structural crack. This is due to the aggregate reaction. This alkali aggregate reaction. This is a reaction with the sodium, potassium, hydroxyl ion in cement paste. This reaction is a deleterious reaction. We can say that. Cracks allow to penetrate to many kind of if this alkali aggregate reaction, so cracks are developed and this will be penetrated throughout the structures, and due to this there may be chances of the penetration of the water into the structure and the structure may deteriorate. So care must have to be taken that in order to avoid the alkali aggregate reaction. Now this is deterioration of concrete due to freezing and thawing. Due to freezing action, it is largely affect the cement paste. So in figure number 8 it shows that the cement paste from the pavement slab is removed. Another case is that in second times the aggregates from the pavement slab is pop up, that is removed from that surface. So these are the some deterioration takes place by freezing and thawing. So this is another exposure, environmental exposure. So we must have to take care while designing such type of pavements and under the freezing and thawing cyclic action. Now therefore efforts made to standardize the different environmental globally. So many countries have made the efforts to make it standardized. So for that in Indians previously in our IS code, durability point of view, or durability is not considered before 2000. Now in IS, when we have revised the IS code, IS 456 2000, we have changed or we have modified it by considering the durability. So this is Indian standard 456 shows the different environmental conditions depending upon our country. So there is they have categorized the environment into 5 different categories. One is the mild, second one is moderate, third one is severe, fourth one is very severe, and fifth one is the extreme. While Japanese Society of Civil Engineering, depending upon the environmental condition of their country, they have categorized the environment into 3 categories, that is normal, corrosive and severely corrosive. Then in year 1992 also they have categorized the environment into different. When there is no risk of corrosion, they have categorized into XO. When there is a corrosion include by carbonation, when there is a corrosion due to carbonation, they have categorized into XC1, XC2, XT3, XC4, and according to that they have categorized their environment. If there is chemical attack, then they have categorized at XA1, XA2 and XA3. Similarly, in US also they have categorized their environment into 3 different categories, that is free, thaw attack, sulfate attack, requirement of low permeability, corrosion protection, reinforcement. So they globally the efforts are made to standardize the environment, and depending upon that, depending upon these guidelines, we have to design the concrete slab. Now we will move towards the durability of concrete. We will see the definition. Durability is the ability to last long time without significant deterioration. Durability is the ability to last long time without significant deterioration. So the service life of the particular structure is remain constant throughout its service life, or for which age it is designed, so it will provide the same service during this period of time. So we can also define the durability of cement concrete is defined as its ability to resist weathering action, chemical attack, abrasion, or any other process of deterioration. A durable concrete is one that performs satisfactorily under anticipated exposure condition during its lifespan. The material and mix proportion used should be such as to maintain its integrity and, if applicable, to protect embedded metal from the corrosion. So, so is there any relation between strength and durability? Yes, definitely there is a relation between strength and durability. So strength of concrete having direct relationship with the durability. Previously it is assumed that the more is the compressive strength of the concrete, more will be the durability. But is it hold good for all situation? Let's check it. One example, if we construct the JT piers, it is sufficient by using of M20 grade of concrete. If we use the M20 grade of concrete, we can definitely produce a better quality of JT piers. But when these piers are subjected to marine environment, whether it is durable, no, definitely no. So special care must have to be taken while designing this JTPS. It should be impermeable. It should not suffer the carbonation. It should not suffer the chloride attack. So such care must have to be taken while designing the JTPS. So nowadays we require the high early strength of the concrete. So due to high early strength of the concrete, we are increasing the cement content. As the cement content increases, water cement ratio is decreases. So due to that, there may be chances of shrinkage crack, thermal cracks. So due to this, there may be a decreases durability. So special care must have to be taken by addition of admixtures, chloride-free admixtures we must have to be add. So such cares we have to be taken while designing such type of concrete. So in high cement content, the creep coefficient of the concrete is decreases. So if creep coefficient is decreases, there is a less scope of relaxation of stresses. So stress relaxation is not possible. So in order to overcome over the stress relaxation, we have to incorporate reinforcement into the concrete. So due to the incorporation of reinforcement, is it possible to reduce the crack formation? Definitely it is not. Only the case is that instead of the we will able to reduce the width of the cracks. So we cannot say that we can achieve the 100% durability by provision of reinforcement. So care must have to be taken while using the high cement content. So volume change in concrete. So hydration process is nothing but an internal volume change. The effect of heat of hydration, the Pozzolanic action, sulfate action, the carbonation, moisture movement, all types of shrinkage, the effects of chloride, rusting of steel reinforcement host all above aspect of volume changes. So due to this all above aspect, we can say that the hydration reaction, Pozzolanic action, sulfate action, carbonation, moisture movement, due to this there is change in volume. So due to change in volume, there may be chances of deterioration or permeable concrete becomes permeable also. So permeability is also lead to volume change, and volume changes results in cracks. Hence more cracks, more permeable concrete, and this is a cyclic action, leads to deterioration, disintegration and degradation, and eventually the failure of the concrete. So care must be taken that while there is a change in the volume of the concrete. So what are the factors affecting the durability of concrete? So durability can be caused by the two factors. One is the external and another one is the internal. We can say that external agents and the internal agents. So arising from the external agents is nothing but which are arising from the environment, And second one is the internal agents which is within the concrete. So what are the external causes? Physical causes are there, mechanical causes are there, chemical causes are there. So physical causes arises from the action of frost and from difference between the thermal properties of aggregate and of the cement paste. Mechanical causes mainly with the abrasion. What are the chemical causes? Attack of sulfate, attack of acid, attack of sea water, and also by the chlorides, which include electrochemical corrosion of steel reinforcement. So, what are the internal causes? Permeability of concrete, alkali aggregate reaction, volume change in concrete. So, these are the comes under the internal causes. So there are the two factors we have seen, that external agencies and the internal agency. So external causes are physical, mechanical and chemical, and internal causes due to the within the concrete itself. So these are the factors affecting the durability of concrete. Let's move towards the next slide. Impact of water cement ratio on durability of concrete. Definitely, water cement ratio plays very important role while uh, designing a durable concrete. So permeability is the main cause of volume change. Higher water cement ratio being the fundamental cause of higher permeability. If higher water cement ratio, more permeable concrete. Therefore, use of higher water cement ratio, permeability. Therefore, use of higher water cement ratio, permeability, volume changes, cracks, disintegration, failure of concrete. This cyclic process will be forms in a concrete. Therefore, for a durable concrete, use of lower possible water cement ratio is the fundamental requirement. So, due to use of this low water cement ratio, there may be chances of we will able to produce the dense and impermeable concrete. But there is a tremendous change in the microstructure of concrete made with the higher water cement ratio and lower water cement ratio. The superior one is the lower water cement ratio. This type of concrete generally formed by using the admixtures. For low water cement ratio, less permeable concrete, it is less sensitive to carbonation, external chemical attack, other detrimental effects, hence improve the durability. So if you gone through this figure, or if you look at this figure, it shows the uh, curves of compressive strength versus the water cement ratio. Compressive strength on the y-axis and water cement ratio on the x-axis. If you observe this curve, the compressive strength is more when the water cement ratio is less. As the water cement ratio is increases, water cement ratio is increases, its compressive strength is decreases. These two are the curves when we are using the vibrator and hand compaction for the compacting the concrete. So hence from this figure it is understand that you will get the maximum compressive strength when the less water content or water cement ratio will be there. However, in low water cement ratio concrete, there is not enough water available for fully hydration of cement paste. So only surface hydration of cement paste takes place. So some part of the cement is remains unhydrated. So this part, this unhydrated core of cement gains constitute strength in a reverse manner. So thus we will conclude that if the water cement ratio is low, the strength of the concrete is more, and we can say that it is we can produce the durable concrete. But care must have to be taken that for different exposure conditions we must have to design the concrete according to that exposure. So we have already discussed one example of the bridge pier. It is subjected in one particular structure of pier. It's subjected to different environments. It's subjected to 4 different environments. So such care must have to be taken while designing the concrete, and this is the responsibility in front of us civil engineer to provide the better concrete which should have a durable. So from that I will conclude this particular part. Thank you very much.